Last class continuation. How to copy the data from one object to another object. We can copy the data from one object to another object in three ways. First one is hard copy. Second one is shallow copy. Third one is deep copy. Hard copy, shallow copy, deep copy. Next one, hard copy. Implement the hard copy. We can implement the hard copy by using equal to operator. We can implement the hard copy by using single equal to operator. We can implement the hard copy by using single equal to operator. Completed. Next one, whenever we are implement the hard copy, in that case, our original data and copied data are referencing to same object in the memory. Whenever we are implement the hard copy, in that case, our original data and copied data are referencing to same object in the memory. Next one, in single dimensional, we can change the original data that is affected in our copied data and vice versa. That means we can change the copied data that is affected in our original data, opposite direction. Vice versa means opposite direction. Next one, in multi-dimensional, we can change the original data that is affected in our copied data and vice versa. In multi-dimensional, we can change the original data that is affected in our copied data and vice versa. I'm observing very clearly. If you don't understand the theoretical, I'm explaining one example. Now I'm taking as a one list object. y equal to simply x. That is a hard copy. Okay, we can implement the hard copy by using assignment operator, single equal to operator. Now observing very clearly x having and y having the same data. At the same time, whenever we are implement the hard copy, in that case, our original data and the copied data are referencing to same object in the memory. That means address of x and address of y. Both are same or different? Both are same. That is the first statement. Second statement, in single dimensional, we can change the original data, then automatically our copy data is affected. We can change the copy data, automatically our original data affected. Single dimensional means single indexing we are using. For suppose in X, I am trying to updating 2 to 20. How to updating X of 1 equal to 20. Internally, our Y is also affected. For suppose I am trying to change the Y data in single dimensional, Y of 0 equal to 10, our X is also affected. This is a single dimensional. Coming to the multi-dimensional, in X, I am trying to change the 5 to 50, X of 3 of 1 equal to 50. Now our Y is also affected. Now I'm trying to change the Y data in multidimensional 7 to 70, Y of -1, -1, -1. Multi-dimensional means we are using multi-indexing. Single dimensional means here I am using single indexing. Multi means more than 1. Equal to 70. Our X is also affected. That is called hard copy. Up to single dimensional is over. This is the example for multi-dimensional. Single dimensional is over. If you don't understand this theoretical part, this is the practical example. Both are same. Next one, shallow copy. Shallow copy. We can implement the shallow copy. We can implement the shallow copy by using following options. By using following options. First one, by using built-in functions. Second one, by using built-in methods. Next one, by using list comprehension. Next one, by using copy function of copy module. By using built-in functions. Second one, by using built-in methods. Third one, by using list comprehension, not list comprehension, comprehension. By using comprehension and by using copy function of copy module. Completed. Next one, whenever we are implement the shallow copy, whenever we are implement the shallow copy, in that case, both original data and copied data are referencing to different objects in the memory location. Whenever we are implement the shallow copy, in that case, both original data and copied data are referencing to different objects in the memory location. Different objects in the memory location. Completed. Next one, in single dimensional, we can change the original data that is not affected in our copied data and vice versa. In single dimensional, we can change the original data that is not affected in our copied data and vice versa. Okay. Next one. In multi-dimensional, we can change the original data that is affected in our copied data, and vice versa. In multi-dimensional, we can change the original data that is affected in our copied data and vice versa. In single dimensional is not affected, but multi-dimensional is affected. At the same time, we can implement the shallow copy, our original data and copy data having the different addresses. Okay, first scenario, by using built-in functions. By using built-in functions. Now here I am using x equal to 1 list 1, 2, 3 and y equal to list of x. Here I am using one built-in function. Now x is and y same data, but address of x and address of y is different. That is a shallow copy. Directly we can take x, that is a hard copy. Here I am using one function. That's why we are calling as a shallow copy. This is the one option to create a shallow copy. Completed. Next, second scenario, by using built-in methods. By using built-in methods. By using built-in methods. For suppose I am taking as a equal to 1 list 1 to 3, b equal to already in the list class, one method we are discussing, that is a copy method. Now a, b, id of a, id of b is different. This is another alternative way to create a shallow copy. Next, third scenario, by using comprehension. Third scenario, by using comprehension. By using comprehension. Now observing very clearly, p equal to 1 to 3 and q equal to comprehension. I am using list for I in p. That I value will be storing into my list. That is a comprehension. Now P having the same data, Q having the same data, but address of P and address of Q is different. This is another alternative way to creating a shallow copy. Third scenario, by using comprehension. Next one, by using copy function of copy model. By using copy function of copy model. Both the scenario by using copy function of copy model. Now observing very clearly, now I'm taking as x equal to 1, 2, 3. Now import Python providing one module. That module name is called copy module, and y equal to copy module providing one function. That function name is also copy function. Which data you want to copy? X data. ID of X, ID of Y is different. This is another option to create a shallow copy.
So once explain this now.
Okay, copy is a one model in Python. Okay, already we were discussing in the first class keywords concept. Keyword is a one model. Just how to access the data, first we need to import that model into our program. Import model name. Copy is a model name. In that model, copy is a function. How to call that function? Model name dot function name. Okay, already we were discussing keywords program at the time of discussing keywords concept. How to access the data from keywords module? First, we need to import keyword. In that keyword module, one variable is available KW list. How to call that variable? Keyword dot KW list. Same like as here, copy is a one function. That function is available in the copy module. Module is a copy and function name is also copy. కాపీ చేయడానికి కదా మనం యూజ్ చేసేది. కాపీ మెథడ్ ఏముంటుంది? లిస్ట్ లో కాపీ ఉంటుంది, అలాగే సెట్ లో కాపీ మెథడ్ ఉంటుంది, డిక్షనరీలో కాపీ మెథడ్ ఉంటుంది. ఆ మెథడ్ యూజ్ చేస్తాం. ఏ ఆబ్జెక్ట్ అయితే ఆ ఆబ్జెక్ట్ లో ఉన్న కాపీ మెథడ్. ఓకే, ఫస్ట్ సినారియో we can implement the shallow copy by using these four options. Next one, whenever we are implement the shallow copy, in that case both the original data and the copy data are referencing to different objects. That's why here we will get the different addresses. Next one, third scenario, in single dimensional, we can change the original data that is not affecting our copied data and vice versa. I'm observing very clearly. Now I'm taking as x equal to 1, 2, 3, 4, 5, 7. Now y equal to copy dot copy of x. Now x data and y data. Address of x and address of y. Address is different. Coming to single dimensional. I am trying to change the x data. X of 1 equal to 20, but our y is not affected. Now I am trying to change the y data. Y of 0 equal to 10. Our x is not affected. This is a single dimensional. Now observing very clearly, coming to the multi-dimensional. In multi-dimensional, we can change the original data that is affecting our copied data and vice versa. Now I'm trying to change the x data 5 to 50. How to change that one? X of 3 of 1 equal to 50. Our y data is also affected. Address is different, but coming to the multi-dimensional, our copy data is affected. Now I'm changing the copy data y of -1, -1, -1 equal to 70. Internally, our x is also affected. Okay, this is a shallow copy. Single dimensional, no affection, but in multi-dimensional, it is affected. So previously hard copy, we can implement the hard copy, both original data and copy data referencing to same object in the memory. We can change the single dimensional or multi-dimensional, our original data, our copy data is affected. We can change the copy data in single dimensional and multi-dimensional. Automatically, our original data is affected. But in coming to the shallow copy, address is different. In single dimensional is not affected, but multi-dimensional is affected. Up to single dimensional is over. Completed. This is a shallow copy. Next, coming to the deep copy. We can implement the deep copy. We can implement the deep copy by using deep copy function of copy module. We can implement the deep copy by using deep copy function of copy module. Deep copy function of copy module. Now observing very clearly the first statement, whenever we are implement the deep copy, in that case, both the original data and the copied data are referencing to different objects in the memory location. It is similar to shallow copy. Next one, the difference is in single dimensional, we can change the original data that is not affecting our copy data. In single dimension is also same. Coming to the multi-dimensional, here also not affected. That is the difference. In shallow copy, address is different. In single dimension is not affected, but multi-dimension is affected. But coming to the deep copy, never not affected. Now observing very clearly, import copy. Now A equal to now B equal to the copy module. One function is available. The function name is called deep copy. Now A and B. Okay, observing very clearly, ID of A, ID of B, address is different. It is similar to shallow copy. Coming to the single dimensional, A of 1 equal to 20. Our B is not affected. I am trying to change the B data, B of 0 equal to 10. Our A is not affected. This is similar to shallow copy. Coming to the multi-dimensional, in the shallow copy is affected, but a deep copy is not affected. Coming to the multi-dimensional, A of 3 of 1 equal to 50, but B is not affected. Here I am trying to change the data, B of minus 1 equal to 70. Our A is not affected. Next one, how to deleting the objects. How to delete the objects manually. Python, we can delete the objects. We can delete the objects manually by using del keyword. In Python, we can delete the objects manually by using del keyword. Del is a one keyword in Python. Okay. Now observing very clearly, I am taking as x equal to 10 and y equal to 20, x plus y. Now delete x. Now again I am trying to x plus y, we'll get the error message, name x is not defined. Already from the memory, x object is deleted. Observing very clearly, for suppose I am taking as a one list object, a print of length of x. Four elements. Now observing very clearly, x dot clear. Okay. Now print of length of x. Now 0, print x. X object deleted or not deleted? X object is available, but empty object. Print of x. Empty list object is there. For suppose I am using del x, or I am taking as a y equal to, okay, print of length of y. Now four elements. Now I am using del of y, print of y. Now name y is not. That is the difference between clear method and del keyword. Clear method to clear the list object, but object is still available in the memory location. Next one, functions. Okay, next concept, functions. A function is a syntax or structure. A function is a syntax or structure, comma, is used to represent the business logics to perform a particular action. A function is a syntax structure which is used to represent the business logics to perform a particular action or operation. A function is a syntax structure which is used to represent the business logics to perform a particular operation. Or another definition, a function is a block of organized, related code. A function is a block of organized, related code to perform a single action. A function is a block of organized, related code to perform a single action. Advantages. Functions provides reusability of code. Okay, reusability of code means write once, use more times. Functions provides reusability of code. Functions provides better modularity of our application. Functions provides a reusability of code. Functions provides better modularity of our application. Okay. That means to reduce the length of the code. Better modularity means to reduce the length of the code. A reusability of code means writing only one time, but the same code we are using into any number of times without writing again. Next one, types of functions. In generally, the functions can be categorized into types. In generally, the functions can be categorized into two types. One is called built-in or predefined functions. Second one is user-defined functions. First one is built-in or predefined functions. Second one is user-defined functions. User-defined functions. Next one, subheading built-in or predefined functions. These functions are already predefined These functions are already predefined for some special purpose. For some special purpose, comma, we can use that functions. We can use that functions only for that particular purpose. These functions are already predefined for some special purpose. We can use that functions only for that particular purpose. Only for that particular purpose. Okay. Observing very clearly. Whenever we are installing Python in our Windows operating system, at the time of installation of Python software, inbuilt we are getting one documentation. Every version is providing one documentation. This is a Python 3.10 manual. On the left side, one option is available, Python standard library. Click on that option. Now it is providing built-in functions. Okay. In these built-in functions, already we are discussing some number of built-in functions. Which functions we are discussing? Bin function we are discussing. Bool function. Next one, CHR function. Complex. Next one, dict, dir function. Eval function. Float function. Format, like as a string handling format method. Internally, whenever we are calling format function, that method is executed. Trojan set. Help function and X function. Hexadecimal conversion. Next one, ID function, input function, int function, length function, list function, max function, min function. Next one, argt, to convert any number system into octal number system. Arg function, to return the ASCII value of the given character. Print function, range function, reverse function, set function, slicing concept, sorted function, string function, sum function, tuple function, and a type function. Okay, half of the built-in functions already we will discussing. Next, I am explaining remaining built-in functions in object-oriented mechanism. Another built-in functions we will discuss. Now, my requirement is I want to display these are built-in function through Python program. Example, write a program to return the list of all the built-in functions. All the built-in functions. Write a program to return list of all the built-in functions. Now observing very clearly. Okay, Python providing one module. That module name is called built-ins. Built-ins is a one module. Previously, copy is a one module. At the same time, built-ins also one module. Now, dir of module. Which one? Our module name is built-ins. Now, the dir function to return the list of all the attributes of this built-ins module. Okay, module contains properties. Properties, it may be either variables or functions or classes. Okay, later we will discussing modular programming. In that situation, we will discussing again. Okay, these are all built-in model properties. Okay, properties may be either variables or functions or classes. Okay, observing very clearly, these are all classes. Built-in exception classes. Okay, now observing very clearly, we are observing any built-in exception class. That class name always starting with which one? Which one? Our class name is always starting with which character? Alphabet. That alphabet is a which alphabet? Uppercase alphabet. Every built-in class starting with uppercase alphabet. Next, observing very clearly, these are all built-in attributes. The attribute always starting with which one? Underscore symbol. These are all functions. I want to display these function names. How to get that one? Our function name always starting with which alphabet? Which alphabet? Which one? Lowercase alphabets. Simply import built-ins. Next one, I am taking as a x equal to an empty list. After that one, for attribute in which one? Dir of built-ins. Okay, the dir function to give the output as a which format? List format. I want to take the one by one element. How to take that one? Simply by using for loop. First one, take this element. Now in that element starting with lowercase or not, if it is starting with lowercase, that element will be adding into our x. Now observing very clearly, if the attribute of first character, how to match the first character? 0. Attribute of 0 dot is lower. Whenever it is lowercase, the first character, that attribute will be adding into our x. X dot append of attribute. Finally, print my x. X contains all the available built-in function names only. So these are the built-in functions. Okay, these are all built-in functions. Okay, first function I'm explaining, ABS function. ABS function to return the absolute value of the given number. To return the absolute value of the given number. If we are passing complex number, in that case, to return the magnitude value of complex number. ABS of it take the numerical data. Already in Python, numerical data can be categorized into 3 types: integer, float, complex numbers. Completed. Now observing very clearly, now ABS of I am passing file absolute function to give the output as the same number. By mistake, we are passing the negative value. In that situation also, we will give the positive format. Next one, we can pass the complex number to return the magnitude of that complex number. ABS of 3.2, ABS of -3, ABS of -6.3. Next one, ABS of I am passing 3 plus 2j. 3 plus 2j. Now what is the output? The magnitude value of this complex number. How to find the magnitude? Complex number magnitude. How to find the magnitude? Magnitude.
Root of x square plus y square, sir.
Okay, magnitude value. This is a complex number. For suppose I am taking as a equal to a plus bj. This is my complex number. In that situation, I want to find the magnitude.
Root of a square plus b square.
A square plus b square.
B square.
That is the magnitude. That is the formula. Okay, here A is 3 and B is 2. Three square plus, yeah, tell me. 9 plus 4.
13. What for the get here?
The square root of 13 means 3.60. If you are interested, we can calculate the square root of 13 in the calculator. Same result we are getting. Completed. Okay, observing very clearly. So the result is 3.60.